I'm delighted you joined us for today's ESPC Community Webinar. Today I'm joined by Ben Weisman, MVP, who will cover REST APIs, AI and vectors in SQL Server 2025. We love hearing guys have to say, so we're enjoying conversation about today's webinar and more on X. Our handle is at ESPC_community and our hashtag is hashtag ESPC26. Tweet us, tag us, and tell us what you learned. Don't forget to check out our Learning Hub, which updated the latest blogs, ebooks, webinars, and how-to videos. You can access and view the Learning Hub by visiting our website, espc.tech, and clicking Learning Hub at the top of the page. Don't forget to check out our next webinar, TMDL, From Zero to Hero, with Roger Unholz, and taking part today, Monday, 13th July at 4 p.m. CEST. To register, visit www.espc.tech/Learning Hub Content Weeks Microsoft Fabric Week. Time's ticking, your future network is waiting. Don't miss the conversations, insights, and opportunities everyone will be talking along after the event ends. Secure your place today and be in the room where it happens. Save €300 with code Fabric Week when you book your ticket. Before you switch on your out of office, make one last move. Secure your place at FabCon SQLCon Europe in Barcelona and take advantage of our early bird rates. Book by the 31st of July to lock in early bird pricing. Then use code Fabric Week to save an additional €300 on your ticket. Enjoy your summer knowing your place is reserved at Europe's leading Microsoft Data and AI conference. If you haven't already, have a chance of winning some Lego from Activities. Scan the QR code to enter today for your chance to win. T's and C's apply. As always, if you have any questions at any stage during the webinar, please feel free to type it in the chat box and Ben will answer them during the session. This webinar will be recorded and added to the Resource Center, where you will be notified by email when it's available. And now I'm going to pass over to today's presenter. Hello, Ben. Thanks for joining us today.
Hey, thanks for having me. All right. So again, good morning, good afternoon, good evening to everybody, depending on who you are. Thank you for the intro. Today, we'll be talking about REST APIs, AI and vectors, and SQL Server 2025. And again, I would like to encourage all of you to use the chat whenever you have questions in between, and we will take them as we go to make sure we get all your questions answered as good as we can. So I'm Ben Weisman. I'm based out of Nuremberg, Germany. I've been working with SQL Server since 6.5, so a little bit of SQL history there. And I'm running a small consultancy firm where we focus on data warehousing, analytics, and BI. The two main things on that thing here that I would like to point out are two initiatives that I'm part of. New Stars of Data, which is very dear to my heart. So if you ever thought about becoming a speaker, maybe becoming a presenter at next year's webinar series or at next year's FabCon, this is your chance. New Stars of Data is your invitation to get started with speaking. We set you up with a mentor to set you up for success, to make sure your first session is a success. So if that's something you're interested in, please reach out to me after the session. And the other thing I'm running is a bi-weekly podcast called Finding Data Friends, where my friend Jess Pomfret and I try to make as many new friends as possible. We ask you 3 questions. What's your favorite food? What's your favorite data thing? What's your favorite non-data thing? So if you want to be part of that as well, please just reach out to me on LinkedIn or by email or whatever. With that, let's get going with our agenda for today. As I've said, we're going to be talking about REST APIs first, because REST APIs are the foundation for anything AI in SQL Server 2025. We will then start talking to AI models, and we're going to use AI models to query your own data. So REST APIs in SQL Server 2025. To get started with that, well, first of all, you will need a SQL Server. That's kind of a given. The other thing is you need to enable the REST API feature. That's all it takes. There is no extra service. There is no extra plugin. There is no extra extension. It's just a setting in your server that you need to enable. And we're going to do that in the first demo. You can then talk to your REST API and, for example, send a request and get some data back. Depending on what kind of API we're talking about, you may have to send a request together with some credentials to get your data back, Or again, depending on what kind of API we're talking to, it may be a device after all. You may not even get proper data back, but just a response code. Like you're talking to your storage array, asking it to take a snapshot, and all it does is gives you a 1 or a 0 if that snapshot was successful, as an example. How does that work? You need a stored proc, and that stored proc is called SP invoke external REST endpoint. And if you've been working with Azure SQL, this stored procedure may not be new to you because it has been in Azure SQL for a while. The big difference is in Azure SQL, it only works against a certain whitelisted list of domains, whereas in SQL Server 2025, it works against any REST endpoint as long as it's using a trusted SSL endpoint. When using that stored proc, you will pretty much always provide a URL. That's a must because you need to know which REST API you're talking against. And you will also usually always cover the response, the output of that REST API. For most cases, you will provide the method. Is it a GET request, POST request, PUT request, etc.? Some payloads, some headers. So providing information to that endpoint, what you're actually trying to do, and potentially some credentials and or a timeout. The default timeout is 230 seconds. The default timeout is 30 seconds. The maximum is 230 seconds. And honestly, if your REST API takes longer than 230 seconds, so more than 3 minutes to come back with a response, honestly, that may not be the perfect fit for a REST API that you're calling synchronous from within a SQL code. This is also how we integrate with AI, because all modern AI, I'm going to say tools or services, they provide a REST API. So we're going to use that feature to talk to our AI endpoint. So you have your AI endpoint, which is nothing but another REST API that you will send your request to and get your data back. With that, I would say we dive into the first demo. So as you can see, I'm on SQL Server 2025, actually using RTM for this. Could have used some of the later updates. Does not matter for this demo. The important thing is you need to be on 2025. None of this works in any of the earlier versions. To prove that I got nothing up my sleeves, I'm actually going to create a new database. I'm going to call it webinar. So we have a brand new database that has no data in it, it has just nothing in it. It's a brand new blank database. The first thing we're going to do in there, we're going to create a master key for encryption, and we're going to use a password for this. In the real world, think about using certificates. The important thing, why do we even need that? We're going to save a credential for a REST API endpoint later on in that database. And whenever you're saving something like a credential, whenever you're saving something that needs to be secured, SQL Server requires you to encrypt it, and you can encrypt it, for example, by using this password. The other thing we're going to do is, and that's what the thing that I mentioned in the earlier slide, spconfigure external REST endpoint enabled and setting this to 1. This is all it takes to enable REST APIs out of your SQL Server 2025. All right, let's try talking to a first endpoint. And I'm using regress.in, which is a public service that just gives you some sample data just to get started with REST APIs in general. So I'm providing my URL, I'm providing my headers, where I'm also hard coding my API key, which is not best practice at all. We're going to get to that in a sec. It's going to be a GET request, and I'm covering the response. Well, when talking to a REST API, you will usually get either some XML or some JSON back. In our case, you can see we're getting JSON. It doesn't look very pretty. Let's see what we can do about that. Because SQL Server actually handles JSON very well. So the only difference in this query to the previous one is that I'm using the OpenJSON function over that. This already looks better, right? Still not super pretty, but we're going to get there. So now we get our data row by row, as we would want it to be able to join it, to query it, etc. But it still has the actual data sitting here in more embedded JSON. Let's do two things. First of all, as I've mentioned, storing your credentials hard-coded in your code is never a good idea. So the first thing I'm doing here is I'm creating a database scope credential. This database scope credential in this case has the type or the identity HTTP endpoint headers. This will kind of depend on your specific REST APIs on how that expects you to provide your credentials. It could be something like username and password. It could be a certificate. It could be a managed identity. All of these things. And that will just depend on how your individual endpoint takes authentication. The other important thing here is the name left to right must match the name of your REST endpoint. So I could not use that credential against an entirely different endpoint. So there's no way for me to just make SQL Server send that credential to one of my, let's call them spoofing endpoints. So the thing I did here now is rather than hard coding my credentials, I'm linking to the database scope credential that I just created. And I'm also using the JSON value function to actually get some proper data out of there. So now this looks like if I was reading data from a table in SQL Server. And from a query perspective, that's exactly what that is. I could either store that in a temp table, I could store it in a persistent table, or I could just use this data as it is and join it, query it, et cetera, et cetera. For the purpose of SQL Server, this is exactly the same thing as if you would be querying a table, which makes this super, super powerful, of course. I'll give you another example. If you're working with REST APIs a lot, many of them use OAuth as the authentication. And that is not something that's built into SQL Server, but you can easily replicate it. So I'm going to use the testing environment of Amadeus, one of the biggest travel providers in the world. And basically what you need to do is you need to talk to the token endpoint first to basically then get your password, your token for the next 30 minutes. So by doing that, I'm creating that token, and then I'm just creating another database scope credential with my bearer token that is valid for the next 30 minutes, which I can then reference in my next query. So in this query, I'm using their API to find a flight from Nuremberg, where I am, to Barcelona, where FabCon is going to be. And this is actually talking to that endpoint and see, okay, I can stop in Frankfurt. It's going to take 5 hours, 5 minutes. This is the price, et cetera, et cetera. Would I necessarily use a SQL Server function to start booking all my future flights? Probably not. But think about all the possibilities, especially if you think about how many services, how many providers, how many offerings out there give you a REST API these days, including, for example, the Azure portal. So you could do an OAuth authentication, create a bearer token against the Azure portal, and then use this to, for example, right after your ETL ran through, take an Azure backup, create a snapshot of that VM, et cetera, et cetera. So integrating this right into your workflows, super, super powerful. As I said, we can also use that to chat with AI. For that purpose, and how I set all that up, we're going to get to that in one of the later demos. I'm running a box that is actually sitting right next to me. So everything we're seeing here is actually happening on-prem on my own box. I'm not using any cloud services. I could use a cloud service for that, but this session is specifically about SQL Server 2025. And if you're still running SQL Server self-managed on-prem, there's probably good reason for that. And one of these reasons might easily be that your data must not leave your premises. All right. The endpoint for that is ai-gpu.lab.bwdemo.io. It's actually an internal box that has an internal IP resolving to that. And to that endpoint, which is backed by Olama and a model, in my case, Mistral, I can basically just chat with that. And I'm just going to start the chat with my question, what is the airspeed velocity of an unladen swallow? So it's going to package all that into little JSON, which is going to be our payload, which we're sending there. And if I do this, the first time it takes a little bit longer, 4 or 5 seconds, because the model needs to warm up. If I'm doing that again, there we go, much faster. And just as if this would be Copilot or ChatGPT or Claude or any chatbot of your choice, every single time I run this query, the answer will be slightly different. So it's telling me, okay, the question you're asking originates from Monty Python, et cetera, et cetera. I can start chatting with a chatbot or with a chatbot endpoint right out of my SQL instance. Again, would I use a SQL start proc to replicate ChatGPT or something like that? No, but let's take this one step further. I'm going to create a little table here called conference sessions. And in that little table, I will go ahead and store some sessions in there, 126 rows. So those are the sessions that will be at FabCon in Barcelona. You can do it, select top one from conference session. Then we see, okay, there's a session on query store basics by Peter Cruz. I got the description. So now I have the speakers, the agenda, the descriptions, the titles for all of the sessions that are on the agenda. I can now take that data and create a prompt by combining my prompt with data from a database. So I'm saying, I'll be excited about attending FabCon Europe in Barcelona in September, especially the session below, and ask it to write me a LinkedIn post about what I'm specifically looking forward to. And then I'm just passing in the session that I'll actually be presenting there. So by taking that and again passing it to my endpoint, I now have my LinkedIn post for that specific session. I could even go one step further and add a little sentence there and ask it to please write it to me in Catalan. So here we go. Would I use SQL Server necessarily to start writing all my LinkedIn posts? Again, the answer is obviously no. But just the last example, think about you have hundreds of items with their descriptions in your database. Now you want to enter a new market. So you need all of these item descriptions to be available in a different language, because right now they're all in English and you need them in German, you need them in French, you need them in Mandarin, you need them in doesn't matter which language. You could just pass them on next to that endpoint and have it do the translation for you. Next, we're going to talk about something called vectors. So what's a vector? What's an embedding? Think that you have any kind of data. It can be text, it can be a document, it can be an image, it could even be numbers, any kind of data. A vector is a numerical representation of that data. That numerical representation means nothing without knowing which model generated it. And we're going to see that in a second as well, and how important that is. So those numbers by itself are meaningless. Combined with the knowledge of which model is behind that, it means a lot. This is an example for a 5-dimensional vector describing the word cat. These numbers don't tell us anything, but let's use that same model and take a look at 2 other words. So we got a cat, we got a dog, and we got a house. And if we take a look at these numbers, you will see, okay, 0.12, 0.08 for cat and dog. That's very close. It's not the same because a cat is not a dog and vice versa. But well, the house is minus 0.45, so very much different. And if we go through the other numbers, we will see the same thing. Closer things have, or more similar things have similar numbers, have similar vectors. So the closer a vector is to another vector, that the more similar they are. So similar content results in similar or very close vectors, and you can then find what you're looking for through context. So you can say, I want a not so expensive bike, rather than doing something like select star from products, where type equals bike and description contains cheap, which may or may not work because maybe nobody put the word cheap even in there, but it may be able to derive that from context. How do we get there? Again, we need a SQL Server, and we already created our conference sessions table that we've just seen a little earlier. So we got our title, we got our description, we got our speaker. We're adding a new column called embedding, and that's going to be of type vector 768. So vector is the new data type. 768 is kind of the precision. It's the number of dimensions in that vector. Think back to our CAD example that had 5 numbers. In that case, we're talking about 768. And that number will, again, depend on your model. Your model will have a certain number of dimensions, and that's how many dimensions your column will need to have if you want to store a vector from that model in there. You need some kind of large language model, including the application to provide it. You need a model in SQL Server, which is nothing but a pointer to your LLM, to your endpoint. In my case, again, Olama, but it could be Azure OpenAI or any other REST endpoint that is accessible. And then there is a function that is also new in SQL Server 2025 called AI Generate Embeddings. You will then pass your context to AI Generate Embeddings, which will pass it to the model, which will pass it to the actual LLM, get your response back, and then you can store your vector in your database. And you can do that in batches, you can do it row by row, you can do it for the entire table. And the strategy for that will mostly depend on how much data do you have. If you have like 120 rows of data, like we do, you just do it all in one go. Let's say you have millions of rows of data and you do it in a single transaction. Let's assume your network fails just before the very last one. That's going to fail everything. So do it in batches in that case. Also, and we're going to point that out again later, but this is very important. Unlike our ChatGPT or unlike our chatbot, A embedding vector is stable. So sending the same context to the same LLM twice, it will get you the same result every single time, which means you only have to update it for rows that have changed or have newly been created. How do you query that? You basically do the same thing. So let's say I'm looking for a session on embeddings. You're going to use the same function, AI generate embeddings, turn that into a vector, look at your conference sessions table, and then use a function called vector distance to calculate the distance between our search vector and the vector of that specific session. That will get your search result that you can then again query using all kinds of T-SQL. There's a couple of caveats and gotchas. Embeddings do take time, so you want to use a GPUs. Important is also GPUs are all or nothing, and that means if your model has 10 gigs and your GPU has 8 gigs of RAM, it's not going to load the first 8 gigs of that model into memory and just swap the remaining 2. No. If it doesn't fit, it doesn't fit, and it's not going to use that GPU at all. So you may have just acquired that very nice and fancy GPU, and your system may still not use it because that GPU does not match the model that you've chosen. Be very clear what goes into your embedding for context. There's a big difference between a name and a bio or a name only. If you're only providing the name and then you're asking a question about a specific session, how is that model supposed to, unless you've given that specific session many, many times or something like that, there is no way that the model will get you a proper answer about that, which also means you may have to consider multiple embeddings or vectors on the same table depending on the questions your users are asking. As I've said before, same input results in the same embedding. If you're using the same model. With a different model, the number will be entirely different. That also means take the time to find the right model. There's very specific models, there's very generic models, and depending on what you're trying to achieve, you may want to use a very specific model for healthcare or fintech, or you may want to use something very generic depending on what you're trying to build. You may even want to look into building your own model, but that's a bit out of scope for what we're discussing and talking about here today. How did I even get there? There's basically 2 ways. One is super simple, and you're just using Ollama FastPath, which is a script by my good friend Anthony Nocentino. You can grab it from his GitHub. It's basically using Docker Compose. So all you do is you clone that repo, do Docker Compose up, and it's going to fire up your SQL Server. It's going to fire up Ollama, and it's going to fire up Nginx as a web server. So all we need to run this. The alternative is you use my script, which is also on GitHub. My script is a little bit better. Why do I think that? Well, mine is running everything on a bare metal or VM Windows box. And the reason why I think that is better is GPUs do not work with Docker except for a couple of very configuration heavy scenarios using WSL2. So if you just want to test the waters, if you just want to figure out, is that even for me? Go with the FastPath because you're going to have that set up before the end of this session. If you really want to figure out how that works with your own data and you have more than 100 rows of data in your table, you definitely want to make use of those GPUs, and you definitely want to do that on either bare metal or a VM to really make sure that you can make use of all that hardware advancements that you're getting there. Whichever way you're choosing is, you're going to have 3 different components. You have SQL Server, you have Ollama, and you have Nginx. Nginx is kind of a helper tool here only because Ollama, which is our equivalent or our AI application that is actually serving the model for us, does not support SSL. And as I've said before, SSL is a requirement when talking to a REST endpoint from SQL Server 2025. So you're going to need an SSL certificate for your Nginx. You need to trust that certificate on your SQL Server. You need at least one LLM, but usually going to have multiples in your Ollama installation. And then you can talk from SQL Server to Nginx, which will actually talk to Ollama, which will talk back, etc. And so you're going to get all your responses. You can use alternative tools. There's other tools than Ollama. There's other web servers than Nginx. If you want, use Internet Information Server as your reverse proxy, which is the only thing that Nginx really does here. These are the most commonly used and / also most lightweight tools for that task, in my opinion. But if you feel like switching them out, or if you're like, well, to get started, I'm actually making things way less complicated. I'm just going to use Azure OpenAI as my endpoint, and I'm just going to send non-sensitive data just to try and test the code. And then at some point, you're just going to switch out the endpoint. That is also perfectly possible and doable, of course, as well. All right, let's jump into the second part of the demo. So I'm going to create a second table where we're going to store our speakers, including their name and bio. Going to store those in my table as well. And then we're going to take a first query look at our conference session. So I'm looking for conference session where the description is like star chatbot star, 0 rows affected. Surprisingly, nobody's talking about chatbots. Let's do the same thing with AI. Okay, everybody's talking about AI, except that that session only includes AI somewhere. It could be availability or failure or something like that. This also doesn't help me, especially for something as short as AI. All right. I'm going to add 3 columns to my conference sessions table: embeddings, embeddings full, and embedding speakers. So one that only has the session details, one that has session and speaker details, and one that only has the speaker details. And we're going to compare the results when querying those later on. So I'm going to add those 3 sessions here. And then I'm going to create a model, create external model. I'm going to call it Olama. This is again my endpoint, which is very similar to the one that we've seen before. This is my API format. It's used for embeddings, and I'm using a model called nomic embed text in the first run here. I'm going to create this, and I'm going to create another one called Olama CPU. As you can see, the code is identical except for this one using the AI minus GPU lab, and this one is using the AI minus CPU lab. Those boxes are entirely identical. Same amount of memory, same amount of CPUs, same amount of same disk configuration, all the same except that the one that's called AI GPU also has GPUs available. So I can run my select AI generate embeddings function, pass some text to it, reference my model, and I'm going to get some numbers back. All right. I'm going to update my conference sessions table, and I'm going to update my embeddings column to the result of AI generate embeddings, title, and description using my Olama model. 5.4 seconds for 126 rows. Let's do the exact same thing with my CPU. And as you can already see, this takes a bit longer. Not going to be horrible longer, but we can already notice the difference. And let's keep in mind, we're only using 126 rows of data here. So about 3 times as long. But growth is actually exponential. So again, assuming you have more than 126 rows of data in your table, that is definitely something you want to look out for. There's another thing I'm not going to deep dive into today. There's also a smaller vector data type by default. They're stored as a float 16. There's the 32. There's also a float 16, which is about half the space. Precision-wise, I have not seen huge differences between them, but also you need a whole lot of data in your table to actually make this a significant or worthwhile save. So if you really have millions or even billions of rows because you're building an embedding across all your support tickets or something like that, then that may be something worth looking into. Otherwise, don't worry. I'm going to do a couple of things here. I'm going to set the bio to just a dash for those speakers that do not have a bio. And then I'm going to update my table again for my embedding speakers and my embeddings full. And what I will then do once that is done, as you can see, they both take more or less equally long, or both around like 6 seconds. I'm just going to delete all the records that did not get embeddings full. This is obviously not best practice in the real world. You can't just delete those items. But there's a couple of instances where the system is not able to calculate embeddings, which is usually the case with null handling, et cetera, et cetera. So rather than dealing with this now, especially for a sample data set, I'm going down the easy route and just delete those 6 rows here. There's also another model called the Onyx model, which is running entirely in memory because everything we're doing here is now going over a network. With the Onyx model, everything would stick in memory. Everything would run on the actual SQL box, which it is not here. I yet have to find a use case, to be honest, where your data is so sensitive that it could not even leave your local network running through encrypted data streams, because the Onyx model has a couple of caveats, one of them being it is super slow and it is not nearly as precise and rich as the other models. So again, if you have data that needs to be so secure that it cannot even leave your box over the local network, that is something worth looking into. Also, again, I still have to find a great use case for that. All right, let's see. Well, still no sessions talking about chatbots. However, I can just use the word chatbots, create a search vector by passing that text in here using my Olama model, and then use the vector distance function. And by doing that, we see, okay, there is a session by Nelly and Sarah, empowering AI agents everywhere with data insights. And we have Kali and Rajat, chat with your data. That both sounds like something that we're actually looking at here. That makes sense. That fits our narrative for that specific search term. What I did here is I also provided a algorithm, the cosine algorithm. There's two more, the dot and the Euclidean algorithm. And if you go back to the literature, they will tell you which one to use for what, etc., etc. Let me show you something. All three of them have the first hit perfectly identical. And again, yet I have to find a use case where they differ a lot. You will get entirely different numbers because, for example, only one of them gets negative. They have different bounds, etc., etc. It doesn't matter. My recommendation is stick to one of them. I stick to cosine because that's kind of the first one that pops up everywhere. But I yet have to find a case where that difference is big enough that it's actually worth choosing one over the other. Don't overthink that part. Let's try something else. Let's say I'm looking for a session by a speaker from Latin America, from Latam. I'm going to compare it against my embeddings, which is only my session details, embeddings full, which is session details and speaker details only. And what we see here is, so the first one, I've never met Evgeny or Pankaj, but I'm fairly sure they are not from Latin America. And honestly, how should the model know? The only thing we've provided here is a session title and a session abstract. So unless there is a good hint in there, like the abstract being in Spanish or the abstract being containing information about the speaker, there is no way the model could figure that out. The other two, especially the one only going against the speaker detail, we're getting the closest distance from all of them, which is kind of how confident the model is that this is the right fit. And I'm 100% sure that Javier is actually from Latam. So depending on what goes into your model, that will have a huge effect on how successful your users will be querying your data against that model. Different models get you different results. So what I'm going to do is I'm going to create another external model. I'm going to call it Olama 2, going against the same location, same format, same model type, but against a different model. The first one was the nomic embed large. This is the MX by embed large. First of all, if I'm using my AI generate embeddings against both of these models with the same text, what you will see is the numbers are entirely different. All right, interesting. That kind of proves the point that those numbers mean nothing except when you know which model you've been using. So if you're experimenting with models, also consider storing that metadata somewhere. Consider saving somewhere when was that generated, with which version of which model, so you're able to replicate and also have better statistics to compare what worked best for your users. If I'm trying to do a vector 768 against that model, I'm getting an error message, and that error message is the vector dimension 768 and 1024 do not match. That is what I've meant earlier. Your model will define how many dimensions your vector needs because your model has a certain number of dimensions, and this is what you will have to use in your code and in your queries. So I will add another 2 columns to my conference sessions table, call it embeddings 2, and I'm calling speaker 2. And I'm going to use the vector data type again, but with 1024 dimensions each. Going to update those 2 columns. This is a slightly bigger model, so it will take slightly longer. So the size of the model will also affect the time that we're using. We're doing both columns in the same go. So we should probably be done here in like 15-ish. Yeah, there we go, seconds. So what we can now do is I'm looking for a session by a speaker from LATAM and pass it against my embedding speaker and against my embedding speaker too. So against the two different models. The first one's still giving me Javier. The second one is giving me Matthias and Tim. I know both of these people in person. I know them personally. I know they're not from LATAM. So this model does not work for that question at all. I cannot emphasize this enough. Take the time to figure out the right model and evaluate the right model for you. Let's take a look at our different example with the chatbots, which I'm going to pass against my embeddings and my embeddings too. The first hit is the same. The second hit is a different one. By the titles of these sessions, I'm going to say both of them are correct. Both of them answer my question. Also, my question wasn't even a real question. It was more of a single word. Take a look at the distances. The second one is much more confident. So apparently, my first model is better on answering questions about speakers, especially when using the right embeddings. The second one seems to be better when looking on queries about a specific session. So there is not even an answer which model is better for which data. It is very specific to the kind of questions you are asking. Let's also say my first query is chatbots. My second query is I want to learn about chatbots. You would think it's the same thing. And it's same-ish. However, the distances change and it flips the order. So there's probably something in that abstract that is making the model assume that you're going to learn more about chatbots in general in the second one, whatever that is. There is no good way or no easy way, at least not at this point, on figuring out why this specific answer was chosen. Another quick thing I want to point out are chunks. So far, we've looked at very, very small sets of data because we've been looking at titles, we've been looking at bios, we've been looking at abstracts. That's easy. That's maybe 1,000, 2,000, maybe 3,000 characters max, and it's all around the same topic. Let's say you have something like a book, but you're not getting that book as a structured data type where you can automatically split it into paragraphs, chapters, pages, but you're just getting the whole book as one big string. Using something called a chunk, using a function called AI generate chunk, you can just split that up automatically because let's face it, you have worst case, you have an encyclopedia and you're looking at the entire book or the entire content of that encyclopedia as a single string. That single string is all over the place. It's not going to tell you anything. By splitting that down, obviously, ideally into chapters or words, etc., or definitions, that would be the best because you could then use that to link back to a specific page, etc. But if that's not something that can be done, at least chunk it into something. I've been using a chunk size of 150 here, only to show you what's happening here. 150 is too little because that's kind of a thing. You don't want too much, you don't want too little. But if you're doing something like 2,500 here, with our data, we would only end up with a single chunk. In my experience, being somewhere in the 2,000 to 3,000 characters range, that is something where you get usually the best results because there is enough context, but there's also not too much clutter. All right. Let's take a look at our last part, vector indexes. What we've done so far is an ENN, an exact nearest neighbor, which means for every single row that we've looked at, we did the vector distance thingy and vector distance then calculated that distance for us. And for 120 rows, as you could see, all of that was happening live. That went all fairly fast. So we have our conference sessions table with all of our embeddings. Let's assume we have more than 120 sessions. Then you may get to the point where you need an index, and that index is a graph index. It's not your usual B tree or something like that. So it's a graph index, and that will dramatically improve your query results. However, vector indexes at this point make your table read-only. If you happen to attend FabCon in Atlanta, or saw the announcements around that, this has been put into preview in Azure SQL, a solution for that. So here is hope, but for now, this is what it is in SQL Server. It's not as bad as you might think it would be, because it's just something that affects your table design. Rather than putting your embeddings on your main table, you would put them on a referencing table. So you're not actually making your inventory table or your item table or your customer table read only, but only that specific querying table. And then there's ways of bypassing that without having too much of an impact. You can then use another function called vector search, and vector search, unlike vector distance, will make use of that index. Okay, let us jump into the last demo. So the first thing we need for a vector index is we need to have a primary key, which we did not have so far. I'm just adding that here. And now I'm trying to add that vector index, and it's telling me I cannot do that. Unknown type vector used in create, drop, or alter statement. This is not entirely unexpected. What Microsoft did is, and as I've given you the hint with that part where I said, well, this is read only, Microsoft decided some things in SQL 2025, the float 16 for the vector data type is another one of those, for example, that either came in too late or that are not working as well as they should yet. So they're still considered preview despite SQL 2025 being GA. So what Microsoft did, rather than picking out a specific trace flag or something like that, they added something called alter database scope configuration set preview features equals on. I basically just signed a contract with that specific database that I'm okay by using preview features, that I'm okay by potentially writing some code where the syntax may still change, by potentially doing something that's not getting the expected results yet, et cetera, et cetera. So what I'm doing here now is running in the GA version, in the RTM version, but the feature itself is a preview feature. So running that same code again, create vector index. I'm doing that on my embeddings column. I'm providing my metric, which can be cosine, which can be dot, which can be Euclidean. Discan so far is the only supported type. And maxstop, I was using maxstop 8. I could have used any number for those 120 rows because, as you can see, 0.1 second, that number really grows exponentially. So 120 rows goes by nothing. 1200 still. 12,000 may already take 30 seconds, and then 120,000 may already take 2-3 minutes, etc. Also depending on the complexity of your data. Creating a vector index, depending on the numbers of data, can take hours, to be honest. So that is also something to consider there. Anyways, by doing that, if I'm doing an update conference sessions trying to change the title, it's telling me data modification statement failed because conference sessions has a vector index on it. So as pointed out before, that vector index just made my table read only. I would need to drop that index, then do the update, and then recreate that index. Still no session talking about chatbots. My data set has not miraculously changed. However, if I'm putting that into a search vector again and use the vector search function, and as you can see, the syntax is slightly different because you're providing the table and the column and the similar to vector and the metric and all that, plus the number of matches here in a slightly different way. And if you look at the Azure SQL implementation, that syntax has slightly changed in the latest iteration in Azure SQL for that. We're getting the exact same result. We're getting the exact same distance. However, this is an approximate nearest neighbor. For a table as small as this, not a problem at all. For big tables, we may get potentially you're saying top n equals 2. You may actually get 3 results or only 1. So that top n is not a guaranteed, and you may also get slightly different results than you get from vector distance. So the results may be slightly different. They're not necessarily less accurate or something. And honestly, I also yet have to see a case where those differ dramatically, even on very large data sets. So if we compare these two, doing vector search and vector distance, again, you see same numbers, same results, all the same. All right, let's finish this up with something slightly bigger. I'm fairly sure most of you are familiar with Stack Overflow, big website that is used as a tech forum, and from time to time they publish their entire data set. So that is what I grabbed, that is what I took. And I basically took two tables from them, one that has about 100,000 rows and one that has about 25 million rows. So here's my search query. I want to build a website using Visual Basic and active server pages. I'm pretty sure this is a query that is still super relevant these days. And within 0.2 seconds, with 91,000 and something logical reads, I'm getting a result. 0.2 seconds for 100,000 rows, that's not horrible, especially keeping in mind all of this is running on desktop hardware. Let's do the same thing with my vector search. 0.1 seconds, so a bit faster, but maybe not fast enough to say, well, this is worth it. But however, 2,800 logical reads, 2,800 versus 91,000. That is a big difference. And that was only the small table with 100,000 rows. So let's do the same thing against our post table, which is all the thread starters until I'm going to say around 2020 is, I think, from when my version of the data set is wrong. It is now going against those 25-ish million rows and doing the vector distance against every single one of them. And well, as you see, it keeps going, it keeps going. And now assume you are a user using an application to query that data that way. Does it matter to you if you're waiting 0.1 or 0.2 seconds? No. Are you willing to wait a second? Probably. 5 seconds? 36 seconds for every single question? Most probably not. And as you can see, logical reads, we're at about 19 million. And now we're querying that same data again using vector search. 0.4 seconds, 5,900 logical reads. We're getting the exact same distances. We're getting the exact same titles, the exact same IDs, etc. So the point here being, this is super powerful, but once you get to a meaningful amount of data in your data set or in your database that you want to query this against, you have to use an index. That gets us towards the end of our presentation. My contact details are up here again. So Anthony Nocentino, who I've mentioned earlier, and we did a little YouTube show leading up to the release of SQL Server 2025 called Anthony and Ben Talk About SQL Server 2025. We're deep diving into lots of the bits and pieces behind the vector indexes and vector search and the vector data type and REST APIs and all that in SQL 25. And should you have access to LinkedIn Learning, there's also a step-by-step course that I got up there. Any other questions you have, put them in the chat now, please, and I'm happy to answer them here. Or feel free to connect on LinkedIn, send me an email, send me a DM, and I'll try to get you an answer on that as good as I can.
Perfect. So thank you, Ben, for a fantastic presentation demo. We'll now move into the Q&A part of the session. So if you have any question, please feel free to type in the chat box now. So the first question is, what should organizations consider before moving AI workloads into SQL Server 2025?
That's a very philosophical question. My first answer would be, what are you trying to achieve? What are you trying to, what problem are you trying to solve? Because what I'm seeing a lot out there in the industry right now is people trying to use AI because everybody does it. A little bit like mobile BI 10, 15, almost 20 years ago, actually. When why are you doing this? What is the problem you're trying to solve? So come up with a very good use case, something that actually helps you move further. And that could be a knowledge base. So the example I gave you on your ticketing system, we actually have our own data warehouse that includes all our Jira tickets because we prefer using our own queries against that over their AI assistant for a couple of reasons. Come up with a good use case first, and then invest the time on how you can actually make that use case come to life in a way that really works for you. So think about the model and think about the goal that you're trying to solve rather than just trying to throw AI on everything. Why would I use that in SQL Server over just being like, well, I could, because all of these things could happen in different places. All of these things could happen in different tools and different platforms. to me, the beauty of REST APIs and AI in SQL Server directly is that it's moving closer to the engine. It is part of the engine, which means I'm making my entire setup slimmer. I'm making my entire setup easier because I'm not going ahead and run 5 different tools, but I'm using one different tool with 5 different options in it, if that makes sense. So yeah, first thing, think really good. What are you actually trying to solve, rather than just being like, well, we're now using AI in our database, kind of like a just because we can moment.
Perfect. Next question is, what governance challenges should organizations consider when storing and using vector embeddings?
Could you say that again, the first part, please?
What governance challenges should organizations consider when storing and using vector embeddings?
Okay. So the biggest governance part to me is how do you generate those embeddings? And as what I see a lot in the wild is people tell me, well, we're still on SQL Server, but we're using some public service to generate those embeddings. So I'm like, okay, you're storing everything on-prem because it can leave your premises, and then you're just basically sending it to some third-party tool to generate those embeddings. So from a governance perspective, make sure you own those embeddings, and also make sure you have someone that really knows what is happening in those models. You're using the right models, you're using the right model provider, and you're using a model that will not train based on your own data. So you're not providing something to feed that model to evolve with your potentially protectable data.
Perfect. And that looks like all the questions. So on the behalf of the ESPC community, we'd like to extend a big thank you to you again, Ben, for taking time out today to carry this webinar. Really appreciate it.
Thank you very much again for having me. And again, anybody that still has questions after this or when watching the recording again, feel be more than welcome to reach out to me, and I'll try to get you your answers there.
Perfect. So that's the end of today's webinar. Thanks everyone for joining, and take care. See you in the next one.
Bye.